Welcome. In this video, we're going to go over the class discussion portion of Unit 1, Activity 2. A biologist is interested in knowing how the concentration of a contaminant in a lake is changing after a chemical spill. This biologist takes several measurements of the concentration of the contaminant after the spill. After 4 hours, she measures 450 milligrams of the contaminant per milliliter. After 12 hours, the concentration has decreased to 60 milligrams per milliliter. The biologist assumes a linear model will be appropriate for this problem. Let's create an equation, then use it to determine when the concentration will drop to 0. So part A, let's identify the questions or tasks in the word problem, paraphrased below. So our question or task is we need to determine when the concentration of the contaminant in the lake reaches 0. Part B, let's identify the important information and organize that information into a table. And really quickly, I'm going to scroll down to Part D and then scroll back up. In Part D, we need to clearly define the variables that will be used to answer the question in Part A. I'm going to go ahead and do that now. So let's go ahead and answer Part D first. And let's say X is the number of hours since the contaminant spill. And Y is the concentration of this contaminant, and this is in milligrams of the contaminant per milliliter of water. Now let's organize our table. Here's X, here's Y. And we have two measurements. After 4 hours, we know there's 450 milligrams per milliliter remaining. And after 12 hours, we know there's only 60 milligrams per milliliter remaining. Now part C, let's extend this table from part B using a linear pattern and then use this extended table to estimate the answer to the question from part A. So if we're assuming a linear pattern, we need to find the slope. And our slope would be 450 minus 60 divided by 4 minus 12. And you should get about negative 48.75. Not about, exactly negative 48.75. And so here's our table, X and Y. And let's include our original information. And now what this slope tells us is that the contaminant decreases by this amount each hour. So after 13 hours, we should have 60 added to this amount, and that'll get you 11.25. And after 14 hours, you end up with 11.25 plus this amount. Please pause the video and try this on your calculator. You should have gotten negative 37.5 on your calculator. So here we have a positive answer, here we have a negative answer. So somewhere between 13 and 14 hours, we know that Y equals 0, somewhere between there. So now we can answer this question. Somewhere between 13 and 14 hours, the contamination will be 0. And now again, part D, we already answered, so I'm just going to write answered in part B. Part E, let's find an algebraic model for our equation using the information in our table from part B. So we already have the slope, so I don't necessarily agree with these instructions. We don't actually have to use our table from part B very much. All we really need is the slope, which we know is negative 48.75. And we also need a point, and I decided to choose the point 1268. You could have chosen any point, so I guess in that regards, you could choose any point from the table. But I liked that this had no decimals, and it was also smaller values than 4 and 450. So I wanted to make my arithmetic really easy. So I'm going to write y minus y naught equals m times x minus x naught. That's the point slope form of a linear equation. So y minus 60 equals negative 48.75 times x minus 12. And space is limited on these notes. So let's go ahead and continue this here. we have y minus 60 equals, and applying the distributive property, that is multiplying negative 48.75 times x first, gives us negative 48.75x. And then we want to multiply negative 48.75 times negative 12, and that'll get us 585. And now we can finally add 60 to both sides. So here we'll end up with 0 on the left, and we have y equals negative 48.75x plus 645. And this is our linear model. Now let's use our model, that is our equation, to find the precise answer to part A. Write our answer in complete sentences using the correct numbers and units. So what did we want to know in part A? We wanted to know when the contamination would reach 0. And if you remember, y represents the contamination level in the lake. So our goal here is to find x when y equals 0. All right, let's do that. 0 equals negative 48.75x plus 645. And that's just rewriting this equation and replacing the y value here with a 0, because that's part of our goal. Now let's continue this algebraically. This becomes negative 645 equals negative 48.75 times x. We can divide both sides by negative 48.75. And this becomes x equals, and actually it's going to be more approximate, so you should use your calculator and try this out. Pause the video if need be. And you end up with 13.230769238. This is an approximation. This will keep going and going. So I'm going to say approximately 13.23 hours. And we can convert 0.23 hours to minutes. So 0.23 hours times 60 minutes, which makes 1 hour, gives us, if you multiply those two, about 13 minutes. So now we can write our answer in complete sentences. The contamination level in the lake will reach 0 at about 13 hours and 13 minutes. You could also write, or 13.23 hours. Now, part E, you need to check your work for errors independently. But one thing we can do, if you remember our table, somewhere between x equals 13 and x equals 14, we noticed that y equals 0, somewhere between these two numbers. So we didn't really know where based on our table. So does our answer actually make sense? So does this answer make sense? Is this precise answer here reasonable? And I'm going to say it is reasonable because it is between 13 and 14 hours as expected. Okay, let's look at part H, and I'm going to move these notes up a little bit so we can see part H better. So there we are. We can see parts G, H, I, and J. So let's look at part H. Let's interpret the meaning of our y-intercept of this equation in the context of this scenario. So I'm going to draw a little mini graph, and we don't really need it, but maybe this will help you see what's going on. So if this is my graph, here is the x-axis and here's the y-axis. And x is time since spill in hours, and the y-axis is the contamination level, and this is in milligrams per milliliter. And again, I apologize for the small amount of space. I didn't write these, so I'm making do. Anywho, so our line has a negative slope, so it's going to look something like this. Our y-intercept is here. So visually what I see, at the y-axis, the amount of time that has passed since x equals 0 at the y-axis is 0 hours. That's what's happening right here along the y-axis. 0 hours have passed because as we move in this direction, more and more time passes. And at 0 hours, we had this amount of contamination in the lake. So it's some positive value that is the amount of contamination in the lake. So let's go ahead and put that together into an interpretive sentence. The y-intercept is the contamination level in the lake at the moment of the spill. Next, let's interpret the meaning of the slope in our equation in the context of this scenario. So our slope was negative 48.75. And remember, this is the change in y over the change in x. So if I go ahead and make this a fraction over 1, it becomes clear that the contamination in the lake is changing by this amount each hour. So let's go ahead and change that into a sentence. So for every hour that passes, the contamination in the lake decreases by 48.75 milligrams per milliliter. And notice I didn't put a negative sign here. I said decreases. And this word decreases takes care of our negative sign. This tells me it's going down by 48.75. If I had written increases, then this would be telling me it's going up by 48.75, but I could have written increases by negative 48, which then implies it's going down, but by then it just sounds confusing. And this is easier to understand if you say the contamination is decreasing by this amount. Finally, part J, and I'm not going to write an answer down for here, explanation only. So verbal. Write your own answer down. Okay. So there are many different ways you can answer this, and so this is why I'm not going to write anything down. So I'm just going to give you some ideas. So the biologists assumed that a linear equation would be appropriate to solve this problem. What does this mean in the context of the scenario? Well, what if their assumption was wrong? What if it's an exponential model? What if it's some other model that would better fit this context? In that case, our work here, our model would be incorrect. So please make with that what you will. See if you can come up with some other interesting explanations in this context. And if you do, post them to the discussion.